Let's solve the given initial value problem. We'll begin by rewriting our differential equation as dy over dx equals to y over x minus e raised to the power of y over x. So here, if we consider this to be denoted by the function f of x comma y and make a substitution x with lambda x and y with lambda y, then we will get back our original function f of x comma y. Whenever this criterion is met, we say that our given function f is a homogeneous function. Now because f is homogeneous, so this differential equation is going to be a homogeneous differential equation. Now to solve this differential equation, we cannot use the method of variable separation. The reason behind this is we cannot express our function f as a product of two functions g of x and h of y, where g is only a function of x and h is only a function of y. That means we'll have to use a trick here. We will use this substitution y over x is equals to v and rewrite our differential equation. So y over x equals to v is also y is equals to vx, and if we differentiate both sides with respect to x, then dy over dx will be equals to v plus x times dv over dx. Now let's rewrite a differential equation. So we have v plus x times dv over dx, that will be equals to y over x. So this is replaced with v minus e raised to the power of v. So the v and v cancels out, and we are now left with x times dv over dx equals to e minus e raised to the power of v. Then we can separate the differentials to get e raised to the power of negative v dv minus equals to dx over x. Now this is in the separable form, so we can integrate both sides. The integration will give us e raised to the power of negative v equals to natural log of x plus the constant of integration c, and we will substitute v back to y over x, which will be equals to negative log of x plus c. So this is the general solution to our given differential equation, but since it's an initial value problem, we will make use of the initial conditions y of e equals to 0, which means that when x approaches e, then y approaches 0. So let's substitute this value into our general solution. We have e raised to the power of, so we have y, so y will be replaced with 0 divided by e equals to log of e plus c. So we have e raised to the power of 0, which is 1, and that's equals to log of e. So log of e by definition is also 1 plus c. The 1 and 1 cancels out, and this gives us c equals to 0. So that means our solution will then be e raised to the power of negative y over x equals to natural log of x. So this is the required solution to our given differential equation.